What's up, YouTube? Let me kill this light over here real quick. Uh, Sorry it took so long. I went out and grabbed another setup, so I have another camera here with another lens specifically for macro photography, so that way I can rule the world and take lots of great video for this channel. So. How is everyone? We got a ton of people in here. There's like 58 people in here. You got Ewan and Norman and Dan Borio and Sean Butler and Old Salty, Matt from Jake from State Farm, Devin Viking, Michael P. Oh boy, we got everybody in here. So we're all here for this, the Nova. I've been a good kid and I haven't opened this box yet. I opened the box that it came in to take a photo of this box so I can have a really cool backdrop, you know, that really cool backdrop. So it is smaller than what I showed you. So sorry about that if you thought the box was ginormous. But I had to make it so people can see it. Tiny box, didn't work. Yeah, I hope YouTube doesn't crash today either. That would be fantastic. So it's weird having two screens. Like I literally can see myself here and see myself there because I have another camera. It's the macro camera. So it should be fun. So like I'll show you the macro camera. So I turn this light on and from over here, I got to add the camera to the stream. And as you can see, we can get some pretty tight action in there. So if I want to show you details of something, like let's say this fancy dancy mosquito hot end here. So let me, right there. So yeah, there's your slice mosquito. I won't be turning autofocus on because that would just be crazy. But yeah, that's what we got here. Hey, we got some alien, some Josh, and from Spain. What's up, Info Mario? So let me kill this light. Let me kill Cam 2. And so what we're gonna do. I mean, this is one heck of a review. Let me tell you. It's a little crazy. So this is just an unboxing and initial, initial like review of like what I think of it, what tests we're gonna do on it, and sharing of those tests and results and stuff because there are some very bold claims. So the 3D, the Nova Hotend 3dpassion.com made on Earth by Vlad Hotend has some very bold claims. I mean, he's also attacked many people, including Joel. Like, who attacks Joel Telling, calling him a shill? He blocked me. I mean, it makes sense blocking me because I was calling him out on stuff, and then he blocked me. And as he was blocking me, he told me I couldn't buy it. So I got a third-party person to buy this, someone that isn't on Twitter, so that way they can't get backtracked. So I got one. Came in sometime last week or the week before. And I'm going to say this up front. I don't doubt this is a really good hot end. I don't doubt it prints really well. I don't doubt it is as good of a hot end as the V6, the Slice Engineering Mosquito, the J-Head, the whatever hot end, the MK8. It will print, and I guarantee it'll print. There are claims like it is completely clog proof. Okay, it's clog proof apparently. It is 400 millimeters per second capable, a total of 47 cubic millimeters per second output, which is higher than the claimed like 35-ish of the Mosquito Magnum and the V6 Volcano. Not as much as a Super Volcano. It comes with stock 60-watt heater. You can go to an 80 or 100-watt heater. And there's a lot of other little marketing things in there. I should stick to that. Is the you can't clog it. It's faster than any other hot end. Has higher flow than any hot. Oh, it's the most thermally advanced hot end for the price. One note about the price. Now he said. Now this is where I learned who Vlad was and learned about this hot end. Slice had the. Let me pull one out here. I think I've got it somewhere. You know what? I'm actually have it assembled into another hot end. so maybe I don't have one to show you. So Slice was marketing the Copperhead, and they were claiming it was the most thermally advanced hot end under $100. And Vlad came in and a few of his friends, and they started ripping into the Slice Kickstarter campaign, saying, "Well, I'm sorry, my hot end is the most thermally advanced. Unless you've actually tested this hot end, I have the most thermally advanced hot end on the market." Now, mind you, you can't just buy this hot end. It doesn't use a standard nozzle. It doesn't use a standard heater cartridge. They're all machined a little different from what I hear, so you can't just take like an E3D V6 heater cartridge and shove it in there. So all in all, to get a working kit, it costs $175. I don't know if the thermistor fit. We're going to find out. We're going to find out if I can take the heater cartridge from this and put it into another printer. If I can take, a Slice, I've got their heater cartridges in here. I've got all kinds of fun stuff in here. So we'll see if I can just stick regular heater cartridges into this and make sure they fit. So, heater cartridges are down here. So, yep, here's a standard V6 heater cartridge. We'll see if that fits. There's 106 people in here. So yeah, it cost me $175 total to get a working hot end. So in the same vein, that's more than a regular Slice Mosquito? Well more than, let's see here. So sliceengineering.com. Let's get the actual price on because those are the expensive hot ends right now. Yeah, so the regular Mosquito, just the hot end will use your V6 thermistor and whatever is $144.99. The Magnum is $169.99. The Magnum is closest to this because that is their high flow. So 170 versus 175. Mind you, for that $175, you will get a nozzle and a heater cartridge and a thermistor. If you buy the other one, you'd probably transport. So, yeah. Carl's already chiming in like, you can't clog it, try this. Yeah, I guarantee I'll probably be able to clog this. Claiming that it's completely uncloggable is quite the claim. It has a 1.87 millimeter bore for the heat break, which is much tighter than other brands. Which again, I feel that if I buy some cheap filament, that it could clog. So, but yeah, I mean, I have a Volcano on this machine. I have 3 Mosquito Magnums on printers. I have a 4th Mosquito Magnum right here. On the way is a copper block and a titanium heat break for a regular V6, so that way I can test thermals on that. Because the main thing we're here for is to find out if this is as good as it claims. Can it get to 47 cubic millimeters per second? Which I don't doubt it can print really fast. Again, I don't want to knock the guy. I don't doubt this is a really good hot end. I just doubt the unverifiedness of it because people share videos constantly. There was a video the other day from someone in the community that was like, I got this. I'm printing at 300 millimeters per second. He's printing on a 300 by 300 bed, and it took 3 seconds to move across. That's 100 millimeters per second. Like it isn't that hard to calculate the actual speed you're printing, because most people think I can just go into Slicer, tell it to print at 300 millimeters per second, and then all of a sudden it prints at 300 millimeters per second. Unfortunately, there's firmware restrictions. There is kinematics, so your acceleration, your deceleration, your curves. Prints go slower in curves. If you're running an 8-bit board, you're not printing at 300 millimeters per second. So there's some issues here with the marketing, and that's why we're all here. I know why we're here. Yeah, and I can clog any hot end. Trust me, I've clogged many. Doesn't blend. Yeah, so, and there's some issues like when he originally sold the 80 watt and the 100 watt heater cartridges, if you just throw that into a regular printer, it'll blow a fuse. So, can you even move? Can you move an X and Y stepper at 400 millimeters per second? Yes, you can. You better have a 32-bit board and hopefully a Core XY. As you can see, I don't have any Core XYs. So going down to the tests that we're going to do, and I'm going pretty quick here because I just want to, I don't want to make this a 6-hour long video of bashing a guy. Like, again, I don't think he makes a bad hot end. I think that the way he presents the product is so high that there's a possibility here, and there's also they're completely unfounded. Because again, no one's actually tested whether it can print at 47 cubic millimeters per second. No one's actually, besides myself, gone into the video and gone, okay, it starts here and it takes 3 seconds to get here, but you said it's moving at 300. It's moving at 100. So again, these are the issues with it. And the other issue is if you print at 400 millimeters per second, what quality are we going to get? What's the point of claiming the top print speed of a hot end where a top speed really doesn't matter? Like, can I even print that fast? Yeah. So I do want to open the box. Again, I want to see what I have. I've seen other pictures of what's inside the box. I know that it's a very small hot end. It's very compact, hence why I have this. And let me grab just a regular V6. Again, hot ends I got hot ends all day. I've got water cooled hot ends. I've got mosquitoes. I've got Novas. I've got V6s, V6 volcanoes. There's just drawers and drawers of hot ends over here. So there's a plethora of things to test. So the testing is going to be very interesting. I have a printer already ready. It's got a BMG extruder on it. I bought the again, you can't mount it on anything unless you buy an adapter. So I bought the tall groove mount adapter, so that way I can attach it to something. So I'm going to attach it to BMG. I'm going to stick the stock fan on it, which apparently is very small. And I'll run, of course, thermal tests. So I'll insert a thermocouple inside the hot end and test its thermals. I will show you really detailed images here on this camera over here. So yeah, I guess we should open it. We should open this, right? We should open this box. So just for sake of cleanliness, I'll clear my desk of these things, my work areas here. The first impression, the packaging is really nice. I got to say, this is like that Apple style, nice, like tight packaging. This thing looks like either it's a really nice cologne or it's a really nice hot end. And the logo is really cool, clean lettering. I'm not going to say anything bad about that. The box does come apart, and inside is a hot end. So you've got the red anodized heat sink and the polished copper block and the fan and some thermal paste and heater cartridge and thermistor, because again, I was told that the heater cartridge won't work from a V6. It's a different size and it's shorter for sure. So let me go ahead and put it under that camera. So let's turn this light on over here. Let's move this thing into position. And let's go ahead and turn on cam 2. And boom. Oh yeah. Oh yeah. So as you can see, let me see if I can flip this thing around here. So as you see, the quote on "it's very polished" is true. The heat break or the heat block is very polished. It has the logo etched into it. PTFE is already cut for the adapter, so that's the groove mount adapter. We've got a red fan. We've got the red anodized heat sink and a tube of gold thermal paste. Yep, I got my nails done. This is actually my bad nail. This is the one I try to do all my tooling with. So let me turn down the exposure a little bit so that's a little less bright. There we go. So yeah, there's your Nova. It is not a ceramic heater. It's just your regular thing. So what's cool about this packaging that I've seen already is actually 3D printed. So if you look at it, it's actually 3D printed and it's got this little fold. So if I flip it over, you can see it's printed on a glass plate. So let's take the actual hot end out. This is all clipped in some fashion. It's actually really hard to take out. How does this thing come out? Does it pop out? Does it slide out? That is really in there. Does it screwed in slightly? I think it's screwed in slightly. Let me grab a tool here. This is fun. Nope, that was the right tool. Nope, it's not screwed in. It's just really tightly in there. Oh boy. Well, okay. Oh, maybe it is screwed in there. Step 1. How to get it out of the box. Because it doesn't slide out, it doesn't push on. I don't want to bend it too much because that would break the break something. Let me. Of course, it uses the even smaller head over there. It doesn't come with any tools. This is why you don't do weird stuff. And something already fell out of the box that looked slightly important. So let me. The fan snaps out of place. This snaps out of place. This unscrews out of place. How do you come out? I don't want to scratch it up. Like, I'm trying not to be too forceful with it because I don't want to bend the titanium heat break, but. Step 1, cut a hole in the box. Yeah, there's nothing in the box. There's absolutely no instructions whatsoever here. Boy, oh boy. Let me open up. I know I got a smaller tool inside my Slice box. Slice does ship you a set of tools. I think I need a smaller Allen key, and this is the, like, tiny Allen key. Give me your tiny Allen key. Okay, the next size down Allen key. Because just in case it is screwed in or something, I have no idea. Oh, well, that's definitely unscrewing. Is that helping me lift it out of place? Nope. Unscrewing does... Oh, wait. I see threads. Let's see here. Does that help me? Does that help? There's a really long screw. I think it is screwed in place. Yep, it was screwed in place. So if I take this to the tiny camera, there's a small screw there. And that's what held it in place. So it doesn't come with the tool you need to take it out of the package. So let's take a look at this. Actually, I can bring it in a little closer. This is all set to manual focus. There we go. So there's your extremely polished, already scratched. Yeah, it's already scratched and nicked and dirty block, which again, I don't understand why we're polishing that. There is a, as you can see, it doesn't use a regular like tool to remove the hot end. You actually have to spend an extra $15 to remove the nozzle from the hot end, which is fabulous. So, and what's cool is, one thing I do really like is hiding back here behind these wires. I believe it's behind the wires. Is it behind the wires? Yep, there it is. So hiding behind the heater cartridge wire, you can see the hole where the set screw is. So the heat break is actually attached with a small set screw. Let's see here. Will it use a regular screw, or do I have to use, nope, regular one. Let's take it apart. So, boom. So here is the 60-watt heater cartridge that's custom made, 5.98 by 18 millimeters. So that's the heater card. Now, it doesn't give you a full length cable. It ends here and there's no more cable. So you have to make your own cable. So it comes with the other end of this, and you make your own connector cable with this. So you don't get a full one. Heat break is made out of titanium. I'll take a look at the chat in a second. I'm going to keep dissecting all this. So here is the heat sink. Again, very well made. You know, anodized red. It's definitely machined and polished. Again, there's a lot of time wasted in polishing. Here's some attachment screws if you want to attach it that way. So, and then this is the groove mount adapter, so you can use it like a regular V6 style hot end. PTFE already cut for you. Zoom in more. I can't zoom in anymore. Well, actually I can. Let's see what the maximum. There you go. There's my maximum on there. As you can see, the machining is not perfect. There's some scrapes and some bad machining parts there and there, some burrs. As we get closer. Yeah, there's the machining tooling marks. Yeah, it's a lot of non-standard parts. Now that's good and bad. I won't knock them for that. So, cheap screws. Nice anodizing though. Anodizing is really nice. Some tooling marks here. So someone used something, and then there's the bore, and it's not polished, unfortunately. He was claiming that it was hyper polished inside of all these things, and you can see that there's some pitting inside of the heatsink chamber, so that's going to be an issue. I'd really like that to be smooth and buttery, but as we can see inside there, that is not smooth and buttery. That is pitted, almost like it was cast. Let's take a look at the heat break. This is supposed to be, again, hyper polished. I see tooling marks all over it. So the claim of being so precise is starting to fall apart. There's some scrapes and scratches. Inside's supposed to be hyper polished, but I won't be able to. Well, maybe I can get some light in there. And it has a very tight bore. Let's unscrew this. Oh yeah, there's flaws in everything. It just, he claimed that it was machined better than any other hot end on the market, and so far I'm not really seeing that. It's well machined. I won't complain about that. And he said the inside of the heat break was polished. So let me grab a backlight. So this will help me with the checking for polishing on the inside. Let's see here. Come on. And is it polished? There we go. He said it was mirror-like on the inside, and I can't get a good angle on it. This is the hard part. This is the hard part, is getting the light just right. And I would not call that mirror polished. It's polished, but it's not mirror polished like that was claimed. I'll get some good photos of this actually in the photo lab. I am a photographer, but I can tell you from experience that is not a like mirror polish in there. That is, and there's some rough edges. So you can see a pit right there. A little dark shadows of pit. So the bold claims are becoming less and less factual. Let's take a look at the polish on this. So again, fingerprints are going to get all over this because it is extremely polished, but you can see the tooling. Look at the tooling lines. So it's not, I would not consider this well machined. I would say it's decently machined. There are a lot of, now see, that, as you can tell, is a mirror, almost a mirror polish inside because of the chrome. It's discolored though. Like that's what a mirror polish would do. You can actually see reflections. But as you can see, it's not perfectly smooth. There's a tooling line that's just in the middle there. There's a bunch of pitting. The nozzle looks, what's that nozzle orifice? It's okay. Yeah, unfortunately, there's no way he could know it was mine. Like, the person who ordered it is not on Twitter. We have no association together. They live in a completely different state. So, I mean, it is really well done, but let's do a comparison. Let's take a look at the machining on this. Now, again, it's not mirror finish, but the machining on the Mosquito, look inside the bore there. Let's get that bore in there a little bit better. Now, some dirt in there, but that is smooth. Like, that's just dirt, those little, like, things there. But that is a smooth internal work. Here's the tight machining on everything. This is the Bondtech nozzle that they hand make. So again, like, this is a brand that also is machined, and I would consider this thing well more machined and polished and true than, again, that's just a dirt spot. But there's definitely some tooling marks in there as well. Oops, sorry. Really hard to stick that in the little hole there. There we go. Yeah, so again, this is your competition. So a little higher priced. You know, the copper heatsink, not so well done. But again, everything is machined well. I prefer this nickel plated block myself because, as you can see, I'm touching it and there aren't a bunch of fingerprints on it. So if we go back to the inside of this, so again, you see there's some pitting and some like machining grooves. So it's not the worst. But inside this heat break, I am not happy with the inside of the heat break for all the how well he said it was machined in grade 7 something titanium. So it's nice, but I am not impressed. So let's take a look. Can I stick a regular heater cartridge in there? So can I stick his heater cartridge inside a Mosquito? Let me unscrew the holder here. It's shorter than a Volcano for sure. I'll get all that comparison stuff up. All right. So it does fit inside a regular Mosquito. So that means it'll fit inside of a V6. Now, I believe the issue with this is it will fit, but the length is too long. Yeah. So the length sticks out. So if I actually were to get this thing in here correctly, I believe the heater cartridge sticks out as far as the nozzle. Let's see, let's bring that in. There we go. So yeah, if you were to seat this thing correctly, as you can see, it actually goes beyond the nozzle here. So because his is 18 millimeters long, and I believe the V6 one is longer. Let me grab the Volcano block. I have them. I have all these things here. One thing I don't have is a copper volcano. That's on the way. I'm going to order one from Printed Solid ASAP. And so here's your standard E3D milled aluminum block. Again, nothing impressive here. And then the height is the same. Might actually be a little shorter. This side is probably better. This is where the nozzle is. So melt zone is actually shorter than a volcano. So you can tell the 2 millimeter difference there. So now there are some really good things about this. Again, I don't want to just knock this thing all day. The design is nice and small. It's very, 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 very small. So let me back this thing up. And let's assemble this thing. Again, I love this part. This is nice that it slides in. It's actually really tight. It's actually too tight. Like, it doesn't want to go in. It's so tight. Yeah, that is not how they claim it to be. But there it is together. Here's your standard V6. Let me turn it this way. So your standard V6 with groove mount is shorter. So it's shorter than the V6. But if you put the Volcano on, you're going to extend this thing an additional distance out. So you're going to save a lot of space. Now, is it smaller than, let's say, a Mosquito? Magnum? No. With the nozzle, the Mosquito's longer. With the small nozzle that's on there, it's shorter. But overall length, the Mosquito is shorter overall. And the melt zone is from the white insulator to the block. So the melt zone is in there. It slides in. It's secured once you secure it in with the pin. There's a locking pin here. But he said it was so well machined it can just slide out. Now let me make sure it's not just like standing on that. Yeah, it's like it takes force to pull it apart. He showed a video where he just like pressed on it and it slid in, and I'm pressing really hard right now and it doesn't want to go in. Like I actually it's actually like coarse. Like if I put pressure on it, there's different levels of pressure. So that is your detailed view. Like you can see the little set screw there. Now, what I do love about this is my favorite part. I love that set screw because that means you can attach the heater cartridge and the thermistor, slide the whole thing together, attach it. If you want to take it apart, you just unscrew here, pull this thing out, and you can do all your work on the hot end. That is something I wish E3D would have done. Like that, like the Hemera, I wish it wasn't another screw-in heater, hot erg, yep, titanium heat break. Heat break, that's the word. So, yep. But that is definitely my favorite part. I think that's actually a great innovation. I wish more hot ends would have a solid heat break and use a set screw. Now, it is rounded. I wish there was like a flat side. Now, you can see he's got flats here, but that's not where it locks in place. It locks in place much lower on the block. So depending on how hard you set this, you could possibly damage the heat break. So it's, there's little nitpicking things. Let me go ahead and attach the top. So let me pop that off. That needs a flathead screwdriver. There's just like, I need all these tools to take this thing apart. Let me go to the main camera. Let me find a screwdriver that'll actually work. Where's my Prusa screwdriver that always works? That's not going to work. That's not going to work. I don't know where they didn't put a flat. I mean, it allows you to rotate it wherever you want, but I feel like a little flat all the way around. That way it's not just like piercing them. And the dragon is very tempting. Boy, I'm still trying to find a small flathead screwdriver. I'll have to grab out of my, I think it's down in here. Is that down? Yep. Grabbing my tool kit. And a flathead. Oh, look at that. I even have a spanner style flathead. Will that work? Nope. Too wide. Too wide. Regular flat. I will take that grub screw out. Let me just attach this top part. Okay, and let's attach this groove mount. So this is with the groove mount. So the groove mount is attached. So let's go ahead and, it is so not as well machined as this video show. Taking this off. So people wanted to see this. And let me get as close as I can. So there's the tip of the grub screw. It's a little sharp, not polished or anything. Heat transfer would be better with something besides red. Heat transfer is probably fine. That is not well machined together. That takes force. Yep. So again, just a red anodized. You can see all my fingerprints on it already just from touching it. I will test to see if materials stick to it worse. And now you can see that I can't use a regular like socket head to take the nozzle off. And the nozzle, let me unscrew that. This is a copper nozzle. And again, no standard nozzle will fit. I'll show you a volcano nozzle on why it won't fit. Let's grab volcano nozzles. So there's the unique tool that's needed. So I mean, you can use a like a wrench, crescent wrench to take that off, I guess. Or you buy his $15 attachment. There's the threading, very nice, and it's a very thin nozzle, very, very thin nozzle. So there's your thin nozzle. And then compared to a regular V6, it's shorter and it's a much smaller size. So he's allowing for more density of the copper heat block to wrap around. So measure the distance. All right. I think we're done doing close-ups for now. Kill this light. Grab out the old thing, and then I'll look at all the stuff that people posted in chat. So the distance between the two flats here is 6 millimeters. And the distance between that and that is 14 millimeters. Distance between this and this is 16, almost 16 millimeters. And 7 millimeters. So it's a 6 millimeter. Let's see if that even fits a regular 6 millimeter. There's a 5. Why do I have a 5 on there? I normally have a 5.5. Yep, here's my 5.5. Ooh, what's this? This is a 6. Yeah, it doesn't fit. The rounds get in the way. What's the nozzle cost? Good question. Let's head over to 3D Passion. So, new window, 3dpassion.com, and 3D Passion store. And nozzles are $21 for this nozzle, $9 for a brass nozzle. And the nozzle tool is $10. So if you want the tool to attach and remove your nozzles, that is $10 for this crazy thing. Close that thing down. So, $21 for a copper nozzle. Mind you, an E3D copper nozzle is going to be the same price-ish. It's a longer nozzle. That's what we're comparing it to. Everything in this realm we have to compare to Mosquito, Magnum, or a Volcano. And then the tool is $10 to remove the nozzle and attach the nozzle, unless you want to use a big bulky crescent wrench to remove it and apply it. So, yep, you can't use a regular V6 heater cartridge. Have to use their 60 watt or 80 watt or 100 watt. I didn't actually check the other thing, which was, can I use a regular thermistor? And I believe I can. There's no change there. You're paying for the tooling. Yeah, yes I am. Boy, so let's take a look at what chat has to say. So let me scroll up here and take a look. I can't see them all. Heat breaks looks longer. The heat break is easy to break. That is a fair assumption, Norman. Again, what you see and what you get are two different things. I don't know, Dave. That was my question too. Let's see. Yeah, some of the older Krakens and stuff like that, they had that heat break that you can actually set screw in, which is amazing. It would be nice with the Red Bear. Hard to tell is, I think there was a little bit of brass on the tip. Measures between flats, same length as Volcano. Nope, it's a little bit longer than the Volcano, or shorter than the Volcano. Cost we did. See what else we got here. Yeah, so that's the issue. Is initially when he sold the 100-watt Hotend or heater cartridge, there was no relay. Most like an Einstein, like I've talked to Joseph about this. He goes, I don't want people going over 40 because again, it's not safe. 50 watts, slightly pushing it with the power output you have, going to a 60, 80, 100. Most printers aren't capable of doing that. Your boards are limited in that factor. He does sell a MOS power module for $15 that you can add to then power the stronger heater cartridges that he uses. For 3 copper Volcano nozzles. Yeah, okay. So yeah, 3 copper Volcano nozzles that are coated are 31 to 44 pounds, so 10 pounds each. He's not yelling. He has eyesight issues, so he types in caps. It's okay. He can get a pass. Tiny. You have a tiny 4-inch titanium crescent wrench. Lucky guy. It is not what you see is what you get. Again, this is why you don't overhype your product. Again, I'm going to state it one more time. I've done it a million times. I do believe that this is a fine Hotend. I believe it'll print just fine. I believe the hype train is much larger than the product itself, and most of the people who have this have no clue what to do with it. So, yeah. Will a 5mm nut screw onto the nozzle? That's a good question. Let me check my magic tool here. I believe it is an M5. It's not an M4. So it is an M5 thread. Using my fancy dancy tool that tells me what the thread size is. I'm impressed by this tiny tube of gold thermal paste. Let me unscrew this and screw this thing back on. Let's see. Higher the wattage heater, more likely to catch fire. Yeah, this is true. Especially if your printer isn't meant to use anything that high and you just strap an 80-watt cartridge. And everything binds. Like, I'm trying to screw this thread back on and it's binding. Let me unscrew this thing again. Why is everything not a common thread size? Why is everything so weird? Let's use these tiny 1mm threads and there we go. There we go. Now I can tighten this thing on. Now what's funny is all I've done is unscrew. Let me turn on the macro camera again. This is, oh boy, this is just getting fun. I need this button. I need it over here. So I only use that screwdriver in my hand and it's already chipping the anodizing off. So let me grab a tool here. So whatever this is, that screwdriver already stripped some of the anodizing off. So yeah, the threads are anodized for some reason. So you do have to buy from them if you want it. What the? Why does that keep spinning? Why can't that? Okay, there we go. Back to me as the main screen. Well, 3D Obsession, I've already criticized it before. Like I reviewed his videos and that, and he took it to the point where he had to block everybody. I mean, he blocks everybody as soon as anyone gives him criticism, and then yeah. So, but I have no choice but to test this with a 60-watt. I've been told that I can swap out the fuse on one of my boards and I can run higher. It's rated for higher, but the fuse doesn't allow it to go to 60-watt safely. So let's go to the testing part. What are we going to do? So there's a very simple testing method for max flow. So a lot of people are like, I don't understand the math for max flow. So you calculate your flow by multiplying the speed at which you're printing. So let's say you're printing at 100 millimeters per second and your line width is 0.5 millimeters, or your line width is 1 millimeter wide, and your line height is 0.5 millimeters. You just multiply those three values and it would give you your value. So let's do that. Let's not cheat. Let's actually use the calculator. And if I was printing at 100 millimeters per second with a 1 millimeter whatever line width times a 0.5 millimeter layer height, I'm printing at 50 cubic millimeters per second. It's very simple to calculate. And all you do is you plug that in and that tells you your max flow. And he's got a max flow calculator on his website. There's max flow calculators, whatever. We just plug in how fast you're printing, what your line width is, and what your layer height is. You multiply that and boom, you're good to go. The issue with this is, can a printer actually print at 400 millimeters per second? I don't think there's a Cartesian that's going to allow you to print well at 400 millimeters per second. You're going to have cooling issues. You're going to have issues just pushing the material out. So you're going to have a bond tech with dual gears. A single gear hob probably won't work. You're going to be limited by the filament because most PLAs max out at 60 to 100 millimeters per second. So you're going to need to ramp up the heat or buy filament. So I've got some of that diamond filament that says it can print to 500 millimeters per second. I've got a printer ready to put it on, but I'm going to do something simpler than that. To test your maximum volumetric flow, you can send G-code. So basically you're going to say extrude length of filament at a certain rate. So you're going to do like a G1 E, 100F, and then the speed. So you're going to be like 10,000, and then you'll see where the extruder starts to click, and that'll tell you when the volumetric flow has been surpassed, and you keep going, and you're good to go. And like this, like it can't. Like again, what Duet tells you is printing, and what's actually printing are two different things. Because someone was posting a video where it showed that it was printing at 300 millimeters per second on the Duet screen, but when you time it, it was only 100 millimeters per second. Because again, it was a 300 millimeter bed, and it took 3 seconds to go from point A to point B. So again, if those Duet numbers, and I know everyone loves Duet, if those Duet values of the actual print speed it was saying were accurate, the printing times would be accurate, and the print times are never accurate. All it can do is send the G code over, and then it doesn't actually know what the speed is. There's no response telling you. So we have to actually push the volumetric flow out, and we can calculate it that way. We can try to ramp the printer up to 400 millimeters, 300 millimeters per second, and then we'll actually time it to see if that length of time took at least 1 second to move 300 millimeters, or if we're going to do smaller, like if we do a 150 millimeter cube, it's going to take half a second to reach from point A to point B. Now there needs to be time for acceleration and deceleration. So yeah. Just to be on speed. Yeah, speed is tough. You're not printing good at 300 millimeters per second. You know, if it's a huge object, that helps. If there's not a lot of detail, that helps. So yeah, there's a lot of misconceptions. That's why this video is important. The series is important to me because there's a lot of misconception. People are like, I printed this at 100 millimeters per second, and it's a benchy. And I guarantee you, there's yeah, Tristan, the web guy shows you asked for, it's not the actual speed. Because if it was the actual speed, why does the print time keep changing as you print? It's not accurate. It's telling you what it should be at that time, not what it actually is. So if when it calls for 300 millimeters per second, it takes into consideration the acceleration and deceleration and stuff like that. So it's not the actual speed. That's what I'm saying. Like I've run Duet printers, and it'll say like I'll be done in an hour, but then it ends up taking 2 hours to print. So how accurate is that speed thing? Because if it's calculating the speed correctly, it should be on the dot correct with the speed. So let's see. You start myth busting. I mean, and again, you can print at 300 millimeters per second. It just, is it worth it? Is it actually 300 millimeters per second? Are we taking into consideration the deceleration and acceleration? Because if we have a jerk of 3 and acceleration of 500, it's going to go wee, and then at that very little bit, we'll get to 300 and then slow back down. So it'll look good. But are we printing at 300 millimeters per second with a jerk of 10 and an acceleration of 10,000, which is going really fast? Or are we just saying we're going to 300? Again, there's a difference between saying I printed this at 300 millimeters per second and I set my printer or my slicer to say I'm printing at 300 millimeters per second. That's the misconception that I want to bring to everyone. Just setting your slicer to 300 millimeters per second does not mean that your print is actually at 300 millimeters per second the entire time. If it prints something that's only a millimeter long, there's a thing called physics. We can't ramp up to 300 millimeters per second instantaneously. There's inertia and mass and things that are moving. We can't just accelerate, in less than a second directly to 300 millimeters per second. So there's a lot of myth involved and a lot of misconception involved. And that's what this Hotend brings you. So it says this prints at 400 millimeters per second or 300. Is it actually, it's actually speed, but only at a point. And that's what I'm saying is at a point's fine, but you're not going to print a benchy at 300 millimeters per second. I printed a 21-minute benchy live on stream before at 180 millimeters per second, and I had my jerk and acceleration ramped in a 32-bit board, and the printer was going to jump off the table because there's mass and things moving around. And Kratos is a 300 millimeter bed with a pretty heavy extruder on it. It might be getting to 300 at some point, and maybe on some longer lines is getting to 300, but the actual print speed is not 300. It's up to 300, if that, because again, setting it to 300 and hitting print and printing something like, you know, if I were to print one of these me prints and I set my printer to 300 millimeters per second, in no way, shape, or form can my printer get to 300 millimeters per second printing this. This is the argument I have with a lot of people with Clipper. They're like, I printed this at 300 millimeters per second. I go, you think you printed at 300 millimeters per second? You told the slicer to print this at 300 millimeters per second, but there's no way in heck you printed this tiny object at 300 millimeters per second. So that's all I'm saying. Like, sure, you reached 300 at some point on objects like this, or a benchy, or a cube. Like I've seen people on the Clipper forum say, I printed this 20 by 20 cube, or 20 by 20 by 20 cube at 300 millimeters per second. You didn't. It never even reached 300 at any time. So it's, again, that's the misconception. That's the issue that we have here. And I've had this argument a few too many times with people about speed. Don't claim the top speed. Did I print this fast? Oh, you definitely printed it fast. You just definitely didn't print it the entire time at 300 millimeters per second. Yeah, yeah. Belgian gets it again, and you need space to get to that speed. So we have theoretical things that, not theoretical. You have actual physical physics involved here. Yeah, and again, I've had that. I've seen plenty of people say I printed this at 100 and it looks beautiful. There's no way. Like maybe on a rail core, maybe on like a really good Core XY, but you're not grabbing your Ender 3, ripping it to 100 millimeters per second and printing something like this without any like visible layer line issues or anything. Like it's just not going to happen. Mind you, this is wood fill. You're not going to print wood fill at 100 millimeters per second anyway. Its flow rate is different. It's like my Ferrari does 197. But yeah. Yeah, and that's the difference. Are you going to buy this, put it on your Ender 3, and have 400 millimeters per second? There's no asterisk. There's no long list of caveats involved with this Hotend. It just says, look at my video on YouTube. It prints 300 millimeters per second, and he keeps claiming that his Core XY printer or whatever that thing is an old cheap machine. It's not. It has really good kinematics. It can print fast. So yeah. So yeah, you get it now. You get it now. Setting it to 100 and actually being 100 are two different things, and that's all I'm saying. Again, I'm not arguing with anyone that you're printing fast. I'm not arguing that you printed, in 20 minutes or 10 minutes, or like you set it to this and this, and it took less time. The other issue is people spin the dial to go faster, and there's things called firmware limitations. You actually have to have a custom firmware because your firmware limits you. If you look at your Creality firmware, nowhere in the Creality firmware does it say you can print. The max feed rate is not 300 on every axis. So a lot of people will change your XY, but they don't realize you also increase the extruder speed because the max extruder feed rate is typically very slow because like a Bowden system can't push filament as quickly as a direct drive. So if you look at those firmwares, they have very slow calculated max feed rates for your extruder. When I made that custom firmware, I set my max speeds to 300. I enabled hybrid stepping mode because there's no way Stealth Chop is running at 300 millimeters per second. It's not going to do 180 either, at least not accurately. You're also going to need to do some other stuff like set the maximum feed rate for the extruder, which a lot of people don't do. So there's just a lot of things involved to print fast. So, if you look at like Prusa's firmware, the max feed rate, I believe, is 200 millimeters or 250 millimeters per second. But the max feed rate on the extruder is very low, which will limit how fast your X and Y go because, again, it's a firmware limitation. Then you look at the maximum accelerations and jerk settings. It's like 10 on the jerk, but the profiles and slicer will be 6 or 8. And then if you look at the max acceleration while extruding, you're at 2000. You're not going to get to 300 millimeters per second even in a 100 millimeter space with those settings. It's going to slowly move through things. So again, speed and actually knowing what true speed is. I guess that's my complaint is there's speed and then there's true speed. What are we actually at? And we need a custom firmware for that. So I'm going to do that. Yeah, there could be, and that's why we have to go to 32-bit. And we have to enable things like hybrid threshold, because there's no way in heck you're printing with a 2208 or a 2100 or 2130 at 300 with stealth chop on. There's nothing. There's no torque left in there. So, but yeah, I am a jerk setting. So that's my story. So I want to give this a good initial review because it's not a bad hot end. Is it everything that the owner said it was? Definitely not. I have to make my own heater cartridge wire. It just comes with this is the thermistor wire. It just comes with this, and I have to splice my own thermistor cable. Why not just include a full length thermistor cord? Heater cartridge, same thing. This is what I get, and I get the connector, and I have to make my own heater cartridge cord. If I'm spending $175, you better damn well include me the whole length of cord ready to go. So, that's just, it gets negatives for that. And it's already chipping. The anodizing's already chipping. The interiors were not as polished as they said it were. And I'll get some really good photos of the inside of the nozzle, inside of the heat break. And it's not like it's bad. It just, again, the expectation set by the owner is through the roof. There's claims. I mean, he claimed that the reason that E3D, had to decrease their price on their titanium heat breaks was because of him, because he made a better, more polished titanium heat break than E3D. So E3D lowered the price. Okay, that's a little out there. And then of course he claims that this is the most thermally advanced. And I will test. I will stick a probe in this thing, heat it to temp, let it sit, and I will measure the temperature, and we'll see. Because I already have values for the V6 with titanium heat break, the Mosquito, a Copperhead, and a Dragon. I already have those temps, so I can literally compare this hot end to them. But I'll rerun them. I will get the actual fan for the Mosquito, so that way it's a fair comparison. It'll be everyone's setup. So as I again clip this, it's the fan that clips on. Looks like a 20 millimeter fan. Let's see how good I am. Is it 20? 25. It's a 25 millimeter fan. But yeah, it's got that E3D style plastic attachment thing on there. I'll attach this on here. I'll get a V6 with its stock thing. Clamp that on there. We'll see if that's more thermally capable. We'll throw a titanium heat break in one. I'll strap on the stock fan onto a brand new Mosquito, and I'll measure the thermals. So yeah, we'll have data and factual data. And again, I'm probably not the best person to test this because I have my biases, but I will stream most of these tests. I will make sure that we can see that we're not fudging the data. They are slow and tedious tests. Like when I did the last thermal tests, it took me over a week because it was assemble hot end, set the thermocouple directly below the heat sink to make sure I'm only measuring the melt zone. So I'm just measuring the temp right above the melt zone. Set it to the temp, let it sit at temp for 20 minutes, record the temp, turn off the everything, let it cool down to the baseline, take apart the heat block, reset everything to make sure my distances aren't incorrect, and do all that fun stuff. So it took a week, and my brain hurted after that. But I will do the same thing all over again, and I will live stream thermal tests. I will live stream whatever we need, and then I'm gonna do print tests. So I'll hook it up onto my printer over there that has just a regular old, not regular old. It's got a BMG on there. It's not really regular old, so I can just mount it using this because there's no way it doesn't fit where an actual V6 fits. Dimensionally, it's the same size-ish, but it doesn't fit on anything I have. So, and I'll scream if he does anything wrong. Yeah, it would be good on a Delta. I should have bought, again, I'd buy another attachment because it doesn't fit on a regular thing. Um, hey man, I called out E3D too, but I ended up sending them the data and they ended up fixing those issues. So I mean, again, there's a difference. You can't catch fish. Oh boy. Um, let's see. I did false advertise the box size. Thanks, Llama. Um, yeah, and again, I think it's a decent hot end, but for what it is, I showed the machining. You can look at the video, you can zoom in all you want. I prefer the machining on the Mosquito. I think it's actually better. I don't like polished. If this thing gets gunked and I need to clean it with a brass bristle brush, am I gonna scrape off this polishing and then have a really ugly looking hot end? Again, there was also another claim. There's a lot of claims. I'll leave that one for later. But for now, I'm going to give a rating. I'm going to give a first impression unboxing rating, as unbiased as I can be, going over the fact that I've already chipped the anodizing on one part of it, and it doesn't fit any standard pieces, so I have to buy his stuff. So again, you have to buy his thing. It's not $100 hot end. You have to buy his stuff. You can't just take off your V6 and put this thing on. You have to buy his hot end, his nozzle, his heater cartridge. Uh, boy, I guess I'll take it apart again and take a look at the thermistor. Let's make sure the thermistor also isn't borked and that I have to buy his thermistor, because that would at least save you a couple bucks. And I guess if we're going to be, it does not come out easily. It does not, like, he showed a video, like, go on his thing, you'll see his video, and it does not come out as easily as that. So let's see. So there's his custom thermistor. Here's a stock brand new E3D thermistor, and it does not fit. So I guess let's go to the other camera here. Let me turn the light back on. As far as it'll insert. So it's as far as it'll insert in there. It goes into the chamfer, and that's it. So you cannot use a stock heater cartridge whatsoever. But I can use, or heater thermistor. I can use his thermistor in whatever I want, I guess. Yeah. So that's a vendor lock. Yeah, basically it's a vendor lock. And again, that's you don't have to. There's no reason why it had to be this way. I can understand the heater cartridge, because the heater cartridge, the block is actually smaller, so you probably don't want a big goofy, heater cartridge hanging out, when you can make a smaller, sleeker one. So that's just me. I'm a crazy man. So I got it all apart. I'm gonna leave it apart. 3D Obsession. What I do is I actually insert a thermocouple directly into the heat break, and I measure right at the zone where the heat sink meets the heat break. And that's been my most accurate, because it matched exactly to the thermal testing using a FLIR camera, like a higher end FLIR camera. It's a thermal camera, but much more high end than the $100 FLIRs. So it matched exactly to that. So I know that the tests are accurate. Why would you want to go? Yeah, happy. See, Ron gets it. Ron gets it. I don't think it's open sourced either. I haven't looked, but I haven't seen anything. But yeah, he did. It's on his website. So if you go to 3D Obsession and you click on the Nova thing, let me go to it. Dun dun dun, Nova hot end. He's claiming with a 0.5 millimeter diameter, at a layer height of 0.25 millimeters, it's reaching 376 millimeters per second. Yep. So heat block is made of nickel chrome copper, grade 5 titanium heat break, 1.87 millimeter bore, which is an issue because out of spec filament, like if you try to buy Matter Hackers build series, their cheaper line filament, it's plus or minus 0.1. So it goes up to 1.85. It could jam it just by that. It is coated. It didn't look coated though. It says it's WS2 nano coated, It didn't look coated at all. Nova Heatsink is the smallest, lightest, and highest performing heatsink on the market. Okay, it's small. This one's smaller. This heatsink is freaking. Look at the size of that thing, and that's yeah. It's not the smallest heatsink. Choice of 3 heater cartridges. Choice of 4. Yeah. Okay, I'm good. Good. Back to StreamYards. Let's see. Boom. Do they have a hard nozzles? Yes. Store, he has. No, he doesn't. The store only has Starforged. Starforged is coated. Mirror polished for easy cleanup. It doesn't say anything about whether or not it can handle. I mean, the coating is HRC 60, but I've tested other nozzles with the coating like that, and they lost the coating after a while, and then you're just cutting through copper, which isn't very strong. Yeah, 3D passion, not obsession. Max velocity usually only infill. Perimeter is roughly half the speed or so. I mean, no, he actually claimed like it's printing at 300. Like he was, look at these perimeters going at 300. Again, these are his claims. I'm just repeating what he says. You're welcome to go to Viral Inventions is his Twitter, and you can look at the claims, like the videos. Like, look at this on the straightaways going 300, and they're not going 300. The infill is not going 300 either. That's actually a lot harder for doing something like hex or gyroid, which uses both axes to move. So you're actually straining the CPU even more. Yeah, are nearly press fit with each other. And they're the heat break barely wants to get inside of the heatsink. So, yeah. And again, and I'm going to compare it equally because again, I did the math. If you bought just all the components for a Volcano, you're going to spend a lot less. It's like $115 with heater cartridge and thermistor and nozzle. So, I mean, I don't think it's with the tiny titanium heat break as well. It's like $115 or $120. So, yeah, it's yeah. Yep. Let's see. Yeah. These are the claims on his page. Well, mind you, he also said that people have used cold pulls to remove obstructions. They weren't clogs, but they had to use cold pulls. Yeah. And I've printed with a stock Prusa extruder at 90 millimeters per second, actual 90 millimeters per second. So, yeah. Cold lube. Yeah, that way it prints faster. So yeah, that's the first one. So let's throw a rating up here. I've got a new rating system. So I'm gonna give this thing a fair rating right now of 2 angry Warkakis. Major missing points is next time include the full cable. Like making people crimp and solder and heat shrink their own cables is just I don't get it. Like I don't think that's nice. Everything being proprietary and locking me into your ecosystem. Nobody's going to make a Nova nozzle or a Nova anything. No one's going to make an attachment. And then you make a nozzle that has to use a special $10 tool, making this $185. So it's $185 plus you have to include your own cables. You need to get the tool because, unless you want to use a crescent wrench, the machining isn't, again, I don't think the machining is better than anything I've seen on the market before. I don't think the press fitting is as good. I actually think it's pretty bad. 2 out of 5. It's a 2 out of 5. So maximum rating of 5, but it wasn't a 5. It wasn't 4. It wasn't 3. It's a 2. Right now, it's a 2. Now, that's just observing the kit and the ecosystem, because again, you have to buy their nozzles, you have to buy their heater cartridges, you have to buy their thermistors, you have to buy all of their accessories from them. Um, so if I buy a Mosquito, I can use any thermistor, any heater cartridge, and a regular V6 nozzle. So mind you, it's a different form factor, and I have to fit it on stuff. Like BMG has an extruder for it, and there's Prusa extruders for it. There's an ecosystem already evolved on it, but it's using regular components. And then when Slice made better thermistors and better heater cartridges, they work on anything. I have a Slice heater cartridge on this printer, even though that's a V6 Volcano. So again, yeah, I do like the 3D printed case. He gets too angry Wakakis. So again, I will say it again. I've said it 100 times already. Probably. I know this thing will print just fine. I don't have any issues. I don't have any qualms. But as an ecosystem, I have issues. For the amount of hype this thing has, I don't believe that the hype is warranted. Because again, how well the niceness of the outside machining is of something doesn't equate to heat transfer. It doesn't equate to usability. A polished, a chromed finished Hotend to me doesn't really matter. The anodizing's nice. I think that's a nice touch. So, I'm not going to hate on that. I think it's great. And again, I wouldn't recommend a Slice unless you have a use for it. There's, again, a V6 is perfectly capable. There's nothing wrong with this Hotend. There's nothing wrong with a J-head. There's nothing wrong with a Mark 8, MK8. It's use case. Do you need to actually print at 400 millimeters per second? What most people are doing is they're slapping a 1 millimeter nozzle and printing with more flow. They're not ramping to 200, 300 millimeters per second, because most Hotends aren't capable of doing that. Also get some measurements on the weight and compare them, because it's not the lightest thing in the world. So 500 millimeters or wall speed test. If the marketing, again, this is as someone who owns multiple businesses, it's better to provide a product and I don't like saying under provide. There's a better word for it. You basically you tell them what it is capable of, and then if people can do more and it over provides, that's the way to go. That's how you should run your business. When you set the bar, again, he's knocking everybody. The guy went directly to the Slice Kickstarter to knock Slice and saying his is better, and there's no proof yours has this. There's no proof yours is more thermally capable either. There's again, he was arguing things that he has no proof of saying. There's no internal heat break tests on his. There's no thermal tests, with a thermal camera done on his Hotends. There's nothing. There's nothing substantial. There's just one person screaming at you saying, "Mine is better." I'm the reason why E3D is failing right now, and E3D has to come out with stuff. I'm the reason why the E3D titanium heat break is lower in price. I'm the reason. It's a lot of me, but there's no actual proof. So the bar was set far too high for me to review it. Again, I'd rather you be, a little I'd rather you undersell the product, and even if you said it prints at 200 millimeters per second, I would believe you. That is a totally obtainable speed. When you throw 300 and 400 out, now we're talking, what printer am I putting this on? What hardware we're doing? Who has firmware that does this? What printers are we, the 2% of people in the world who have printers that print that fast? Okay, why? What if it doesn't? What if someone buys their Ender 3 and they hit it to 300 and they do the timing thing and it doesn't print 300? What do you do? Do they get a refund? Again, I don't. Yeah. Marketing is important for the quality of product, and as someone again who runs multiple businesses, none of them in manufacturing, mind you, you can't. I don't tell people that they're going to get the best photos in the world, because again, I'm just a photographer. People always say that you're just a photographer, Chris. I get it, but again, I undersell my product and over provide. That's just what we do. So. Yeah, yeah. Volumetric. Oh yeah, we'll definitely do that. Like I bought it with the 0.5 millimeter nozzle. It doesn't offer a 0.4, which is probably why he considers it clog proof. Because most of the CF materials, they want you to have a 0.5. They minimum 0.4, but they really want you to have a 0.5. Um, undersell me a Tesseract. uh, yeah, Carl gets it. So that's all I'm saying. Again, you will get. I don't doubt you'll get wonderful prints out of this thing, and I don't doubt I'm going to have stuff. But again, I won't give a final review until I've done all the thermal tests and actually have verified which one is thermally more capable than the other. I will also print at least 300 print hours with it of various things. Unfortunately, I guess I have no choice but to print carbon fiber with the Starforge nozzle. I am beta testing nozzles that are copper and coated with a material that should allow infinite time with carbon fiber material, so I can compare. Like this printer has done 4 kilograms through a copper nozzle of carbon fiber CF. Uh, this one over here, the Hemera, also has done 4 kilograms of carbon fiber CF using a just copper nozzle. That can't be worn down apparently. So I will now, we've got things. So dude, I want tacos all the time. And yeah, it's a lot of hype. And there's there is the other side of marketing, and that's there's a couple of photographers who do this, and they're super famous, and they do the negative. They say things so bold and claim things so far and outrageous that they cause a steamroller effect. People share that, they get more views, and then people go, "Oh my gosh, is it that good?" And they buy it. So unfortunately, this is now in the hands of someone who will then test it and give you practical feedback on, is it that capable? Is it a bunch of bullcrap? And even if it does go to 400 something millimeters per second, it's not any better, or I can already tell you it's not any better or worse than a V6 Volcano, a Slice Mosquito, a J-Head. Your prints aren't going to be better. So it just, I can tell you that straight up. And if I'm wrong, I will gladly tell you I'm wrong. But I'll print everything from gray test cubes to Pikachus to Dickosaurus Rex. I don't care. Like, I'll print it. And there's not going to be a quantifiable difference. There's not a quantifiable difference between any of those hot ends that I've mentioned and print quality. It's settings, materials, and how good your kinematics are on your printer, not on how fancy your hot end and how well machined your hot end is. Having a nice machine nozzle sure does help, but polished stuff that doesn't matter all the time makes, yeah. What color? A lot of them. Yeah, I mean, again, I have material that if I had some Maker Geeks, I guarantee I'll clog his hot end, because that shit sometimes gets to 2 millimeters. Again, it's you can't claim it's clog proof. Like, he'll just, if it clogs because of imperfect filament, did it clog because of the hot end or because of imperfect filament? It's still clogged. Like, I don't get the marketing. Add $50 of upgrades, put it on Kickstarter and triple the cost. Yes, that's what I do. uh, I don't know if it outperforms. Again, Nozzle X uses a lower quality high tool steel, so it's completely going to be unaffected, even if the coating wears off. I have worn the coating off of my Nozzle X, but I am the random guy who prints 60 kilograms of carbon fiber a year. So if somebody wants to know, like, how good of a nozzle is against carbon fiber, I will tell you. But I'm going to end the stream. This was good. I hope everyone is filament dry. Yes, filament dry is as bad as it says. It's a fan and a heater cartridge. It's not going to dry your filament. And I will also not clean this thing the entire time. I will let it build up gunk, and I will see how well it cleans off. Yeah. Yeah. So again, there's bad filament. Really? Their original one was plus minus 0.1. Maybe they've changed. Maybe they got a different distributor. I know that Sunlu. That's all I know is Sunlu makes their filament. So if you like Sunlu, it's Build Series. So, because again, it's all white labeled. I'm hooking mine up to A-Trax. I have no idea. Probably not well. Yeah, I can show you the nozzle again. If I didn't lose it already, it's so tiny. There we go. Turn the light on. Turn the box this way. Throwing this thing back on stream. Let's see. Closer? Closer. Yeah, there we go. So, yeah. And custom nozzle. Hey, no problem, Ron. It's always fun streaming. So very small. Look at my chipped nail. That's the one I crimp all my wires with. So that hand always has the crimped nail. All right, I'm out of here. You guys enjoy. If you want to buy a Nova, definitely I would. It's not a bad hot end. So I prefer other things at the moment, and we'll see what the final results are as we get closer to getting final results. Other than that, stay out of trouble. Happy printing, happy modding. And yeah. Sean Butler, I wish I was a year behind on tech. I've got a Chimera over there and things in there and all kinds of stuff. So packaging, best part so far of the Nova, besides the fact that he screwed the hot end into the box because that was painful. So good night, stay out of trouble, happy modding, and we will see you very soon. Give me about a week to get a printer set up and running. I'll do the thermal test first because they need to be fresh. I want them to be unused. You know, I don't even know what power fan this thing is. I'm hoping it's 24 volt. If it's 5 volt, doesn't matter. I'll find something. I'll find a board to make it so I can hook it up and test it. So on that note, good night, and see you all later. Don't forget to hit the like button because that helps me out a lot.